When we think of plastic bottles, we tend to think of words like cheap, convenient, and durable. But what happens to plastic after we're done with it? Many of us know that recycling is the commonplace way to help in relieving environmental strain that plastic causes. However, that solution has pitfalls. Plastic items that cannot be recycled again either accumulate in landfills or end up littered in nature. And the overconsumption of single-use plastics is often cited as the reason why plastic is taking over the world, but it's actually from a mismanagement of our waste. It is a detriment to the environment, and it will be here for thousands of years. Realistically, even if we move away from plastic to a sustainable alternative, we will still be left with mountains of its waste for generations to come. The system is flawed. So how do we start turning it around?
There is a growing market for creating plastic alternatives that are meant to help consumers reduce their plastic waste. Unfortunately, these material alternatives are more costly than single-use plastic items. Besides being less affordable, biodegradable plastic items may also be less accessible, making them harder to find at the average store. In addition, these biodegradable plastic items have a special recycling process, and some individuals may not have access to the resources or the facilities that allows them to properly recycle those items. Instead of creating another alternative to plastic, we decided to directly deal with the problem of the waste by focusing on its management, starting with the consumer. By allowing the consumer to have a more active role in the plastic waste management, they will form a deeper connection with the life cycle of plastic and the consumer's part in that cycle.
How can we do that? Well, we can by changing the way we recycle plastic, therefore introducing Biohome. So then, what is Biohome and how does it work? Well, Biohome is a DIY plastic composting kit where we provide you the plastic eating organisms and their homes, and you provide the plastic. There are 3 types of kits that are available: mealworms, waxworms, and mushrooms. Each kit includes the organisms, their Biohome containers, a user's manual, and a substrate that contains a mixture of the organism's natural substrate where they thrive in, along with plastic. Each organism degrades different types of plastic. Mealworms are ideal organisms to break down polystyrene-based plastics such as styrofoam. Waxworms can break down polyethylene-based plastic like PET and LDPE. And the enzymes of oyster mushrooms can break down LDPE and biodegradable plastic like PLA. And depending on the user's plastic recycling needs and their willingness to interact with the organisms and the organism's needs and maintenance, there is a kit for every user. In addition to providing the Biohome kit, we also provide customer support and will be available to answer questions regarding organism care to concerns about what kind of plastic to put in the decomposer. To help maintain, grow, or start a new plastic eating colony, Biohome also provides starter colonies of mealworms, waxworms, and mushrooms.
Biohome uses 3 different organisms: mealworms, waxworms, and mushrooms. So, when we were choosing the materials for the containers that would hold them, we considered their needs for stable temperatures and airflow. They needed something that was sturdy, but was also in line with our mission. The Biohome is made of stoneware, wood, and fine metal meshes. The containers that hold the living organisms are made of stoneware, which provides them with an insulated environment and protects them from the weather. The stoneware is easy to clean and durable. The structural frame for the containers is made of wood because it's lightweight. However, the wood is kept away from contact with the organisms because they can degrade it. Since the worms can chew through fabric and plastic as well, we chose metal meshes. This ensures worms don't escape and allows for better air circulation. These materials have a more circular life cycle compared to hard plastic, which is commonly used to make a traditional vermicomposter.
Mushrooms or fungi are decomposers that use the enzymes that they excrete from their root structure, known as mycelium, to degrade the matter around them. Certain species of mushrooms also have enzymes that allow them to break down plastic, such as low-density polyethylene, polyethylene terephthalate, and polyurethane. These types of plastic are found in plastic bags, bottles, biodegradable plastic bags, and a variety of plastic materials from wheels to fabric, respectively. A type of fungi that has been recently studied to be able to break down plastic is white rot fungi. White rot is a type of wood-decaying fungi that can break down lignin, which is the structural polymer that gives wood and bark its structure. The common and edible oyster mushroom, Pleurotus ostritus, are a type of white rot fungi that has been recently studied to have the ability to enzymatically break down plastic, such as LDPE and biodegradable plastic. Like other white rots, oyster mushrooms have the ability to break down wood. The enzymes that are involved in this process have the ability to break down plastic. The addition of the oyster mushrooms in the Biohome allows for the user to recycle their plastic waste while at the same time grow mushrooms that can be used as fertilizer. While oyster mushrooms are known to be edible, the oyster mushrooms used in the system may not be, and therefore more research is needed.
Mealworms are the larvae of darkling beetles, a beetle that originated in Africa and is known to eat plants and decaying leaves. These types of beetles is common in the US, and the mealworms are commercially produced as chicken and reptile feed. While they may be seen as a treat for our feathered and scaly friends, these little critters can do more than just that. They can actually break down plastic. Mealworms are basically tiny bioreactors that can break down plastic such as polystyrene. And recent research reveals that mealworms can chew through and digest plastic like styrofoam, and their ability to completely digest it and use it as a food source is due to their microbiome. The combination of their tiny mandibles that allows them to chew through the styrofoam and the particular combination of bacteria, digestive enzymes, allows these critters to completely digest plastic. Mealworms are low maintenance, affordable, and efficient, and therefore are an essential component to the Biohome unit. And while mealworms are commonly used as animal feed, more research still needs to be done regarding the consumability of mealworms that eat plastic.
Similar to mealworms, waxworms are the larvae of the wax moth. As the name suggests, these insects are known to lay their eggs in beehives, and their larval form's main diet is beeswax. Given the nature of these organisms, they can be seen as pests if not contained. Like plastic, beeswax is a polymer, a long molecular chain that is made of the same repeating units. Waxworms are also mini plastic degrading bioreactors, and their ability to completely decompose it is mainly due to their digestive enzymes. This allows the waxworm to completely munch through LDPE films, such as plastic bags. However, other studies demonstrate that the waxworm's gut bacteria may also contribute to their ability to eat long polymers. This further aids in their consumption of plastic. While waxworms are shown to be efficient plastic biodegraders, one of the consequences of them eating plastic is that they have been shown to produce ethylene glycol as a waste product. More research is necessary.
The product we are designing is also important for developing new ways to teach people about the importance of recycling, composting, and natural life cycles. The user puts plastic in and waits some time for the fungi and worms to consume it. Thus, they become familiar with the amount of time and care it takes to get this material back into the natural ecosystem. The pattern of buying and throwing away has become more and more prevalent in American culture. The pollution caused by the plastics being made and thrown away gets hidden from the consumer because of offshore production and landfills that are far away from cities. We want our product to help the consumer take back some of the responsibility that's being hidden away, because ultimately we are paying for plastic's convenience with pieces of the planet. The product we are making connects the user with their responsibility and allows them to learn how to get rid of the plastics they're using with mushrooms and worms. It also familiarizes the user with decomposition, reminding them of the importance of sustainability for our planet and for our species.